In this class, we are going to discuss some questions in limits. Now, our first question is limit x tends to x dot mod of ax square plus bx plus c divided by ax square plus bx plus c is equal to question. Here given alpha and beta are the roots of this quadratic expression, such a way that this x naught is such that alpha less than x naught less than beta. The graph of this quadratic expression is either open upwards or open downwards. If this a is greater than 0, the graph open upwards, and if a is less than 0, then the graph open downwards. Since alpha and beta are the roots, so this graph should cut the real axis. That means the graph will look like this. This is x-axis and y-axis. So this is a graph for a greater than 0, and this is a graph for a less than 0. Here this point is alpha, this point is beta. Since alpha less than beta, alpha less than x naught less than beta, so x naught be a point in between alpha and beta. Let this be our x naught, this point. Similarly, for this graph, alpha, beta, and this will be a point x naught, that is between alpha and beta. Look at this graph. For a greater than 0, in between alpha and beta, the portion of the graph is this. That is, this is along negative y-axis. Means the expression ax square plus bx plus c is less than 0 in between alpha less than x naught less than beta. That means for a greater than 0 and alpha less than x naught less than beta, the graph is negative. That means ax square plus bx plus c is negative. So the modulus become mod of ax square plus bx plus c, that is equal to minus of ax square plus bx plus c. Okay. A less than 0, this graph is positive, that is along positive y-axis. So in this region, the graph is positive. So for a less than 0, ax square plus bx plus c is positive. That means mod of ax square plus bx plus c, that is equal to ax square plus bx plus c. Okay, now this limit become limit for a greater than 0, limit x tends to x naught mod of ax square plus bx plus c divided by ax square plus bx plus c. This is equal to limit x tends to x naught. This modulus become minus of this term. That means minus of ax square plus bx plus c divided by ax square plus bx plus c. This will cancel. Is equal to minus 1. A less than 0. This limit become limit x tends to x naught. Modulus function become positive of this quadratic expression. That means ax square plus bx plus c divided by ax square plus bx plus c. This is equal to 1. So limit x tends to 1, x square minus 1 minus x minus 1 into ln x by x minus 1. So for direct substitution, this becomes 0 by 0 form. Okay. So we can write this limit as limit x tends to 1, factorize this term, that become x minus 1 into x plus 1 minus x minus 1 into ln x divided by x minus 1. So x minus 1 is common in numerator and denominator. So we can get cancel x minus 1. So this is implies limit x tends to 1, x plus 1 minus ln x by 1. So substitute the value. This become 1 plus 1 minus ln 1. This is equal to 2 minus 0. So answer is equal to 2. Now our question is, we want to find the fractional part of this limit. Here the limit is limit n tends to infinity. Summation r varies from 2 to n. R plus 1 into sine pi by r plus 1 minus r into sine pi by r. Okay. Now for n is equal to 2. This expression because time become 2 plus 1. That is 3 into sine pi by 2 plus 1, that is sine pi by 3, minus 2 into sine pi by 2. This plus, when n is equal to 3, this implies this plus, this term plus n is equal to 3, 4 sine pi by 4 minus 3 sine pi by 3. And n is equal to 4, this become this term plus 5 sine pi minus 4 sine pi by 4. And this continues. And the last term become n plus 1 into sine pi by n plus 1 minus n into sine pi by n. Okay. Now add this all terms. This term and this term get cancelled. This and this get cancelled. This and this term get cancelled. And the cancellation in taking place in this manner. Okay, so this term get cancelled. So the remaining terms are this term and this term. So this is equal to n plus 1 sine pi by n plus 1 minus 2 sine pi by 2 to sine pi by 2. Now apply the limit. Limit n tends to infinity. When direct substitution, this become infinity into sine pi by infinity minus 2 sine pi by 2. That is 2 into sine pi by 2 is equal to 1. So this term become infinity into sine 0, pi by infinity is equal to 0, minus 2. That is equal to infinity. This becomes sine 0 becomes 0. Infinity into 0 form. So this is infinity into 0 form. So convert this limit into standard form. So we can write this limit is equal to limit n tends to infinity sine pi by n plus 1. I am taking this term into the denominator. So divide by 1 by n plus 1 minus this 2. Okay. So as to make into standard form, I am multiplying the denominator expression by pi. Here also numerator also by pi. So this expression is the standard form. That is sine of same angle by same angle, and this is the form sine 0 by 0 and sine 0 by 0. That means 0 by 0 form. Limit become equal to 1 into this pi minus 2. That is pi minus 2. The value of pi is 3.14 minus 2. That is equal to 1.14. Our question is, we want to find the fractional part of 1.14. That means fractional part of 1.14. That is equal to 0.14. Is the answer. Now our question is, limit x tends to 0, square root of 1 plus x sin x minus square root of cos 2x whole divided by tan square x by 2. That is equal to question. So by direct substitution, this become 0 by 0 form. Okay. we can write this limit as limit x tends to 0, 1 plus x sin x whole raised to 1 by 2. And cos 2x can be written as 1 minus 2 sin square x the whole raised to 1 by 2. Okay, whole divided by tan square x by 2. We can expand these two terms by using binomial theorem. So using binomial theorem, this implies limit x tends to 0, this expression becomes 1 plus 1 by 2 into x into sin x plus the higher order terms minus this term become 1 minus 1 by 2 into 2 sin square x plus all the higher terms whole divided by tan square x by 2. Now this one and one get cancelled. So the remaining terms become limit x tends to 0, x sin x by 2. This become plus sin square x whole divided by tan square x by 2. Limit x tends to 0, tan mx, mx is an angle, divided by mx is equal to 1. So I am going to convert this into standard form. So writing here x by 2 the whole square. So as to balance the equation, x by 2 the whole square is written here also. So this is balanced. Now the value of this limit is equal to 1. Value of this limit become 1. That is limit x tends to 0, tan x by 2 by x by 2 the whole square. That is equal to 1 square is equal to 1. This limit is equal to 1. So this can be written as limit x tends to 0, x sin x by 2 divided by this x square by 4 plus limit x tends to 0, sin square x divided by x square by 4. So 1x in the numerator and 1x get cancelled, and this become limit x tends to 0, 2 times sin x by x plus this 4 goes to the numerator, limit x tends to 0, 4 times sin x by x the whole square. The value of this limit is equal to 1. So 2 into 1 plus 4 into the value of this limit is 1 square. That is equal to implies 2 plus 4, that is equal to 6. So 6 is the answer.